Hi, this presentation will cover the state of the art of the extensive uses of big data in the transportation industry around the world, showing how most of its applications are already a reality, but still pass unnoticed in many cases by the masses. The first versions of Google Maps were simply focused on getting people from point A to point B. At first, travel times were calculated based on the distance and using historic traffic data that Google could gather. Definitions were vague, such as low or heavy traffic. In 2012, though, they moved a step forward, incredibly improving their predictions. This map shows every country where the service is available. So, how does Google know what traffic is like on the roads at every time of the day in around 70 countries throughout the world? In short, they mine data from the users and return useful information to the very users in order to optimize people's journeys. For those concerned about privacy issues, phone companies had been knowing where phones are for a long time based on the strength of a signal to a cell tower. With several millions of people using Google services every day on smartphones connected to the internet and tracked by GPS, the company has found itself owning huge amounts of geographic data. Google can then combine speeds of vehicles and compute average speeds for each section of the road. The output for the users is a color-coded map. Congested roads are red, yellow means some traffic, and green stands for a road that is moving along. For the future, it has been proposed that Google suggests around 5% of its users alternative routes to reduce the chance of congestion in the first place. A similar development has been recently put in place in China. On a highway that encircles Beijing, all traffic signs have been replaced with smarter ones that use the same real-time color coding as Google Maps, making them much easier for foreigners to understand than Chinese characters. The boldest project regarding the use of big data in transportation took place a few years ago in England and had a much more realistic approach. London has been for centuries the model city for transportation, leading the world with cutting-edge technologies and innovation. The Tube, London's underground, is now the world's biggest subway and was also the world's first, since it was built all the way back in 1854. For comparison, this is a map of what the Tube looked like in 1930, and on the right what MARTA looks like today. Transport for London, the Capital Transport Authority, was also the first in the world to introduce automatic self-driving trains, and the world's first car payment system, the Oyster, shown on the left, which is basically the same thing as the Breeze car, which is shown on the right. A few years ago, the entire city started undergoing a major transformation powered by big data. While they're still doing hardcore engineering kind of works, such as building new lines and fixing bridges and roads, the greatest improvements were made in the efficiency of the system. This time, the approach was holistic, touching everything, from cars and buses to subway and pedestrians. In other words, the city is seen as a delicate ecosystem, where when something is altered, thousands of other things and people are affected. 2 years ago, they started rolling out free Wi-Fi throughout the entire network. This allowed to track huge masses of people during their everyday commute, providing insight on what trains were used the most during peak hours, allowing authorities to optimize the service in real time. Using an approach similar to Google Maps, Wi-Fi tracking and the Oyster card allow Transport for London to identify where people are at any given time. For example, in the morning, commuters flow between north and south, but in the evening they seem to move west and east. Furthermore, the system gives back information to the commuters with an app and a website that serve as a news feed for instantaneous traffic and delays updates. A bigger amount of open data is available on the institution website shown here. All the data shown here is available for private developers to build their own applications. As I said earlier, the approach was holistic, so that pedestrians were involved too. While CCTV cameras, simply known as security cameras, have been monitoring vehicles for a long time, they are now starting to monitor crosswalks, or as Britons like to say, zebra crossings. Cameras equipped with proper software can recognize crowds of people waiting to cross, and can calculate people's density and people's absolute number, and use this information to smartly shorten or lengthen the duration of crossing for cars and pedestrians. The take home here is that if one traffic light changes, all other traffic lights nearby have to adapt and change too. This often happens near highly populated places, such as in proximity to train stations and universities, where the traffic is highly unpredictable. This infographic shows how long people wait for transit in the world's major city, and it's a lot. Big data could represent the new hope for commuters that waste precious time every day, because it could be able to make public transportation, which has been historically dysfunctional and expensive, more efficient. I hope you could see how the London system is a model that should be copied and improved anywhere else in the world, especially here in the USA. Thank you for watching.